Hmm. Trigonometry, Chapter 3, Radian Measure in the Unit Circle. Section 3, the Unit Circle and Circular Functions. Video 1, the Unit Circle, Quadrant 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, we learned about applications of radian measure. This section, we will learn about the idea of radian measure and how it relates to the unit circle and the definition of circular trig functions. In this video, we introduce the unit circle and focus on specific points in quadrant 1. Currently, we have two perspectives of trig functions. The first of which is when we had an angle in standard position, with the point xy not equal to the origin on the terminal side of x. Then the six trig functions of theta were defined as they have been all along. Sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, cosecant of theta is r over y, secant of theta is r over x, cotangent of theta is x over y, where r is the distance from the origin to the point comma xy, and specifically r was the square root of x squared plus y squared. Now, for an acute angle theta in a right triangle with adjacent side ADJ, opposite side OPP, and hypotenuse HYP, we have instead sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, tangent of theta equals opposite over adjacent, and their reciprocals. For our third and final perspective of trig functions, we need to first introduce the unit circle. The unit circle is the circle on the coordinate plane whose center is the origin, 0, 0, and whose radius is 1. What makes a unit circle unit is the radius of 1. Now, as a consequence of this center and radius, the equation of the unit circle is x squared plus y squared equals 1. Now, let's see for which points in quadrant 1 on the unit circle we can determine the precise coordinates. Now, a couple are pretty easy over here at 1, 0 and up here at 0, 1, but I mean somewhere actually inside the quadrant. We do this by taking advantage of what we know about 30 degrees, 45 degrees, and 60 degrees. Let's start with 45 degrees. So we'll put a 45-degree angle in standard position, if you will. But here's our standard 45, 45, 90 triangle with legs of length 1 and hypotenuse of length square root of 2. In the unit circle, however, the hypotenuse has length 1 because it's a radius of that circle. But using similar triangles, we can scale down the 45, 45, 90 triangle by a factor of the square root of 2 to bring the hypotenuse down from the square root of 2 to 1. So in other words, we're going to divide everything by the square root of 2. Now, if we scale down the legs by the same factor, we get legs of length 1 divided by the square root of 2. Or if you rationalize the denominator, square root of 2 over 2. So here's a 45, 45, 90 triangle that resides inside of our unit circle. Therefore, the coordinates of the point on the unit circle, right here, associated with the 45-degree angle, are the square root of 2 over 2, comma, the square root of 2 over 2. That's going to be an important ordered pair to remember. Now, let's repeat the same process for a 60-degree angle. Here's our 30, 60, 90 triangle with sides 1, square root of 3, and 2. And here's the 30, 60, 90 triangle embedded on our unit circle. Now, because the hypotenuse in the unit circle has length 1, we scale down the 30, 60, 90 triangle by a factor of 2 to bring the hypotenuse from 2 down to 1. Well, that means that the legs are now going to be 1 over 2 and square root of 3 over 2 like we see here on the bottom right. Therefore, the coordinates of the points of the unit circle associated with 60 degrees are 1/2, comma, square root of 3 over 2. Now, for 30 degrees, we simply reorient this triangle that we currently have, since it does contain a 30-degree angle in it. If we reorient it, the 1/2 and the square root of 3 over 2 will basically switch places. Now our 30-degree angle is in standard position, and the coordinates of the point on the unit circle associated with 30 degrees are the square root of 3 over 2, comma, 1/2. So here are the points in quadrant 1 with known coordinates on the unit circle. Notice we include points at 0 degrees, 1, 0, and 90 degrees, 0, 1. You want to memorize this. Memorize these now. Your life in trig will be much easier if you do. All the way around from 0 to 90, stopping at 30, 45, and 60. Now you try. Pause the video and try the following. What are the coordinates of the points on the unit circle associated with the following angles? If you need to go back in the video and take notes, do it. But pause the video now and give it a try. All right, here's your fair warning if you haven't paused the video. Solutions in 3, 2, and 1. I kid you not when I say that knowing these coordinates on the unit circle can save you a lot of time. Okay, I'm going to stop